Hello, everyone, and welcome back to Learning with Jelly. So, today is going to be our first video in a PROC SQL playlist. So, I'm going to create a playlist of multiple SQL videos, especially focused on PROC SQL for SAS, so that you know all there is to know about this extensive SAS procedure. So, let's go ahead and look at our agenda. Our agenda for today, we're going to do a brief introduction to SQL. So, if you've never heard of SQL or you need a refresher, we are going to introduce exactly what SQL is. I'm going to explain some differences between the PROC SQL that we use in SAS versus another tool such as MySQL or SQLite or Postgres. We then are going to create some tables that we're going to need in future videos. We're going to insert some data into those tables. And then finally, we're going to summarize with some key points. So let's get started with an introduction to exactly what SQL is. Now, SQL stands for Structure Query Language. And this type of language or programming is used to interact with what we call relational databases. So if you see the acronym RDMS, that just means Relational Database Management System. So you're working with a database that has relationships amongst tables. And we're going to talk about what comprises a database on the next slide. So why database? Why not just get a CSV file or Excel file or a text file? Well, databases are great when we want to store large amounts of structured data. So, financial data for banks, they have tons of customers. They want to store that data in a database across multiple servers so that they can analyze it. Customer transactions for companies such as Target or Amazon is going to use some type of database structure. When we're doing inventory management, there's a whole bunch of use cases for why we prefer databases than just a static local file. Because in reality, the data that you want, it needs to be real-time data. So you need to access a database to get some real-time data so that you can do some great analysis and data manipulation. So let's talk about relational databases. What actually comprises a relationship database? So relational database are made up of tables, a schema, and keys. So as you can see, I list the definition on the slide here. So a table is going to be a specific entity where rows are records and columns are fields. Sometimes you may see that columns are referred to variables or records are referred to observations. It's all the same thing. It's a table. And we want a table that's focused on one specific thing, such as a customer table. That table should only have information about customers. A store table. That table should only have information about the stores, etc. It also has a schema. And this keyword schema is the structure of the actual database itself. So it is going to list the names of the fields or variables. So, say for instance, in the customer table, you have customer name as a field, customer zip code as a field, customer email address as a field. So, the schema is going to list out the field names and also tell you the type of field. Is that a text field or a character field? Is that a numeric field, such as zip code, where you have a number? Is it a Boolean field that has true or false, etc.? The schema is also going to tell you the relationship among the tables. So it's going to tell you that table A can link to table C. It may not can link to table B. So it's going to tell you what exactly is the relationship between the individual tables because databases have to comprise of more than one table. Keys are what we are what's used on tables to help identify unique values. So when you hear that term primary key, a primary key is the field that uniquely identifies every record in the table. So if it's a customer table, the primary key may be customer ID. If it's a store table, the primary key may be store ID. where that ID number is unique for every record and observation in a table and it can't be missing. So it has to be a unique, non null identifier. And it also is this concept of foreign keys. And foreign keys is what links primary keys to another field in another table. So if you look at this visual on the right here, we have an employees table and a sales table. And if you can see here, this yellow key is going to denote what field is the primary key of that table. So in the employee table, the primary key is employee ID. That makes sense because every employee should have a unique ID, and primary keys are unique identifiers. And for the sales table, the primary key is sale ID, which makes sense. Every sale should have its own transaction ID number. And we can link these two tables, as you can see, by employee ID. So that is the relationship. This is why it's called relational databases. The tables have some type of relationship amongst each other, and they have these primary keys that can uniquely identify rows in a nice structure for analysis. So, what are some basic SQL operations? So, regardless of the SQL software or the SQL database engine you use, whether it's Oracle, Postgres, SQLite, we're going to focus on using Proc SQL through SAS. There are some basic database operations that goes across all of these different SQL flavors, okay? So, if you know one, you can easily pick up another flavor. So you're going to see keywords such as select, where you're able to retrieve data from one or more tables. Insert, that we're going to see today, where we can add new records or rows inside of a table. Update, where you can modify records. Delete, where you can remove records. Create table, where you can create a new table in the database, and so much more. Keep in mind that a lot of these operations is going to be specific for data engineers or people who actually are administrators. They don't want just anybody in the company deleting out a table. So you want to make sure that you use the delete keyword sparingly, the update keyword as well, so that you're not overwriting the database. So just be very careful on some of these operations. But you're going to see these operations in pretty much all of the SQL engines, regardless of what software you use. So now let's briefly talk about the difference between Proc SQL and MySQL. I just chose MySQL because it's a popular SQL database engine, but this still applies to things like Oracle and SQLite and Postgres. So what are the differences between all these different flavors of SQL? So, as I mentioned, there are many, many flavors of SQL where the foundation of the SQL language is the same, but there may be enhancements based off of who made that tool or software. So, Oracle will have its own enhancements to their SQL. Microsoft will have its own enhancements. We're going to use SAS. So SAS has its own enhancements where you're able to use certain SAS options and certain SAS statements that you wouldn't be able to use in other flavors. So think of it as all ice cream. All of these flavors are all ice cream. They're being made of milk and sugar. But adding an enhancement like chocolate syrup or strawberries will change the flavor, but not change the fact that it's all ice cream. Okay. So, this is why if you pick up one language, you can easily understand another SQL language because it's all ice cream at the end of the day. It's all SQL. So proc SQL is a flavor form of SQL that is going to use those SAS enhancements, and it's going to have slightly different syntax. Maybe it's a single quotation marks for text in one language. Maybe it's a double quotation marks in another language. That's what we're talking about when we say slightly different syntax. MySQL is another flavor. It's its own database engine, and it won't have SAS enhancement, but it'll still have those basic SQL standards. And as you can see on the right-hand side of the screen, these are some flavors. Not all of these are SQL engines. Some of these are NoSQL engines, which stands for not only SQL, and that will be in a future video. But there's tons of different SQL flavors out there. But we're going to focus on Proc SQL and SAS. Okay, so let's get started with Proc SQL and SAS. And before we can actually write a whole bunch of queries, we need some data, right? So we're going to start from actually creating our own database, inserting data into that database, and then pulling out some information. And then in future videos, we're going to talk about how to get summary statistics in SQL. We're going to talk about how to join tables and all of that nice stuff. So let's get started. So we're going to create 3 tables of our database. It's going to be an author table, a books table, and a sales table. So we're going to create a small database for our bookstore. You can call it any bookstore you want. I'm going to call it the Learning with Jelly bookstore because why not? So the basic proc SQL syntax, you're going to start with that proc SQL keyword, end it with a semicolon. After you put all of the statements in between, you're going to also end that with a semicolon. And then just like any other procedure in SAS, you're going to type run and end that with a semicolon as well. So clauses are a distinct part of SQL statements. The select clause, the from clause, the where clause, and they perform a specific purpose. Most of the clauses that we're going to learn in this playlist is going to be a part of the select statement. And the select statement has multiple clauses. The from, the where, the group by, the having, the order by. All of those are keyword clauses that does something. So let's go ahead and create this small database. So the first table is authors, and it's going to contain the author ID, the author name, and the birth year. And we're going to use the create table operation within Proc SQL to do this. So as you can see with the code on the right-hand side, the first thing that I did was created a folder in SAS On Demand for Academics. So my folder is called SQL Work, and this is where I'm just going to store my database in. So I'm going to call the library test SQL in my lib name statement, and this is going to create a library for me to store all of these tables. So the first things first, I call proc SQL, end it with a semicolon. I then called my create table and I said, hey, I want to create a table called authors that's stored in this test SQL library or database. And I give it 3 fields or 3 variables. I give it the author ID, the author name, and the birth year. Notice that the author ID is a character of 5 length, and the author name is a character of 255 length. So why did I choose author ID to be a character and not a number? Right? It's an ID. It's going to be like 1001. The main reason is if the number isn't meant for mathematical operations, like I would never add 2 to somebody's employee ID, I would store it as a character versus a number. But if the number is something that I may can perform mathematical operations on, such as sales or profit, I would actually store that as a number. So I'm going to keep the author ID as a character here. Okay. And we're going to dive into the SAS interface to put this all together at the end so you can see the code. The code is going to be linked down in the description below as well. So now we're going to create a books table. So the second table is going to be called books, and it's going to contain author ID, book ID, and genre. So a quick thought-provoking question here. Can you think of what data type each of these variables have to be? What is the data type that we're going to need for author ID? Is it going to be character, numeric, Boolean, integer, etc.? What is the variable type that we need for book ID? And what is the variable type for genre? So as you can see, I created that next table right underneath the authors table, still in the same proc SQL step. And I created a table called books. The author ID is a character. I kept it the same as the author's table. No need to switch up on variable types within a database. It makes things cumbersome. And then my book ID is also a character because I'm not going to do any math on a book ID. If the book ID number is 11111, I'm not going to want to add 2 to that ID number or else it would be a different book. So because I'm not performing any mathematical operations on book ID, I'm going to keep it as a character. And then genre, such as romantic, comedy, nonfiction, sci-fi, that is going to be a text variable as well, so it's character. So all characters in my books table. And our last table is the sales table. And that's going to contain the book ID, the genre, and the sales. And this is just going to be the number of books that were sold. So if the sales is 10, that means I sold 10 copies of that book. If the sales was 50, that means I sold 50 copies of that book. So once again, can you think of what data type each of these variables have to be? What is the data type for book ID? It's going to be the same as in the books table. What is going to be the data type for genre? That also is going to be the same as in the books table. And what is going to be the variable type for sales? Can we perform some type of math on sales? I think we can. So as you can see, still in the same proc SQL step, I create a table called sales. I have the book ID as character, the genre as character, and sales as numeric. Awesome. So now we have created our tables. But keep in mind that for SQL, the create table just creates an empty table with the variable names. It doesn't actually put records or rows in the table. In order to do that, we need to insert some data. So the keyword that we are going to utilize to insert data inside of our table is going to be insert into, and that's going to add the data records to our table. So note that when you're adding data to your tables, character fields need to be surrounded by quotes. Okay. It doesn't matter in SAS if it's single or double quotes. I just keep it single for now. In SAS, each record is after the keyword value. So as you can see on the right-hand side of the screen for the authors, I have 4 value keywords. That means that I have 4 records or 4 rows in the author's table. Okay. And in this case, I have the author ID, which is 1001 as a character. The author name is John Doe here. And the birth year is 1973. Okay, so this is going to be 1 row in my author's table. The last record gets our semicolon. So in this insert into statement, I add as many records that I want, and the last one is going to get that semicolon. So pay attention to the semicolons. SAS will yell at you if you miss a semicolon, and it's so frustrating. So please go back and check your semicolons. And I can add all of these values within the same proc SQL step. So in this case, in my authors table, I have 4 rows. In my books table, it looks like I have 6 rows. Now, why would I have 6 rows in my books table when I only have 4 authors in my authors table? Well, you agree that an author can write more than 1 book, right? So it looks like in this case that John Doe, based off his ID, wrote 2 books. And Jane Doe also wrote 2 books. Okay. And then in my sales table, where I have my book ID and the genre, I have the amount of books that were sold. Okay. So let's go ahead and hop over into SAS Studio so we can see this code. And the first thing that you're going to want to do, and if you don't have an account for SAS On Demand for Academics, I'm going to put a link to my first video. It is free. I tell you all about how to set up an account so you can start practicing your code for free online. So I'm going to expand this server in files here. And then I'm going to click on files and I'm going to click new folder. And I'm going to create some type of folder. Okay. You can call this folder SQL for me, whatever you want to call it. So just create a new folder. I created a new folder called SQL Work, as you can see. So I'm going to click on it so it's highlighted in gray. I'm going to right click and I'm going to scroll down to where it says properties. It might be hanging off the end of my screen some, but that is okay. If you right click, you can click properties. And here's my location. And I want to copy this location. Okay. So now I am going to do a lib name statement at the top. And if you don't know things about libraries and lib names, I'm also going to link that in the description below. I teach you all you need to know about libraries. But I'm going to call this library test SQL. It can't be more than 8 characters. So if you get an error, make sure that it's 8 characters or less, and make sure that it starts with a letter or underscore. And I'm going to copy that folder path that I just copied in as single quotes. And then when I run this one single line here, I can expand libraries on the left-hand side, look at my libraries, and I have test SQL. You won't have anything here right now because we didn't run our actual proc SQL code, but you will be able to see that you created a library. Great. So now this is our long proc SQL step that we saw in the PowerPoint. So we start with the proc SQL semicolon. We create our 3 tables here. We insert into all 3 of our tables, and then we click run at the end. So I'm going to copy and paste this piece of the code in the description below, but I highly encourage that you type it out yourself, add some more variables if you would like, add some more records if you would like. That's going to help you build some muscle memory. But I'm going to highlight this, and then I'm going to run it. And this is what I get. So it's going to show me that I created this. Sorry. I see that when I look at the output, I have my authors table that I created. I can hit the arrow down and look at my books table. I can hit the arrow down and look at my sales table. So we have all 3 tables that we just created with this one step. Great. Now, since we actually have data, okay, we can start doing some SQL. Okay, we did some SQL for creating the database, but now we can really leverage SQL to get some information about the database. We could do some analysis, like the average amount of sales, all of that good stuff. But for now, let's just focus on selecting fields or columns from the tables. So in this proc SQL step that you see here, I have proc SQL. I select author name, and I want to select it from my library called test SQL in the authors table. Notice that after my entire query, I did a semicolon, and then I did a run with a semicolon. So we have 3 semicolons here. So keep track of those semicolons. So when I run this, I expect for it to only give me the author names out of my author table. So let's run it and see what it does. And it does. It gives us our author name: John Doe, Jane Doe, Oliver Doe, and Shauna Doe. Okay. Now, what if I wanted to select everything from a table? I want to select all the fields because I want to figure out what fields exist in the table to begin with, if I'm not familiar with the tables. Then I can use this asterisk symbol. So this asterisk symbol is above the 8 on your keyboard. And I have the proc SQL select asterisk or select star from the books table. So I want to select all the variables from the books table. So when I run this, I get out a nice little structured table that selected everything from my books table. Now, be cautious when you utilize this select asterisk because, like I said, you're working with large amounts of data. You could be waiting forever in the industry for this query to run because it's going to try to select all the Netflix customers. You don't want to do that, okay? You want to stop it. But for our purposes here, it's a very small database, which is 4 records, so we can select everything. And I'll show you how to limit what you select using the limit clause in a future video. So stay tuned for that. So let's hop right back over so we can drive this home and make sure that we have a good summary of the key points. So we talked about the select clause, and the select clause here is going to be able to select those variables that you want to output. And if you do an asterisk, it's going to select all fields. So this example is selecting the author name from the author's table. The next example is selecting everything from the books table. So we learned a lot in part 1, and we're going to learn even more in part 2 and part 3. So go back and review this video. Make sure that you copy the code below and that you practice. But let's have some highlights. So SQL stands for Structured Query Language, and it's great when working with relational databases. Relational databases are made up of tables, schemas, and keys. Proc SQL is just a special flavor of SQL just for SAS. The create table operation is going to create an empty table with field names. The insert into operation is going to allow you to insert records into a table. And the select clause is going to select the fields you want to output. So that was a summary of all that we learned in part 1. So thank you all for tuning in for part 1. I hope to see you on part 2. Please subscribe, like, comment, hit the notification bell, and thank you for supporting Learning with Jelly. Bye-bye.